They sized me up. Okay, we're at 2:30, so you're going to get started now. My name is Tyler Barden. Hold on, this is a little bit loud, sorry. I'm the program manager for the Bandwidth Optimization Services Group in Windows Networking, and I'm here with Andrew Cunningham. He's a software development engineer on our team. His name should be in bold up there as well. I was just pointed out that my boss has found the first mistake in my slide deck. The two of us are down here to catch some rays here in SoCal and tell you a little bit about BranchCache, so I hope you're in the right session. Okay. Let me set the stage. Let's travel back in time to the late 1990s. It's a time of the Chicago Bulls, good dance music, and a lot of local area networking. So if you're not working off a zip disk, you're probably saving your documents to a server that's just down the hall. Okay, fast forward to 2011. You're sitting in your company's branch office, watching the Miami Heat choke in the finals, maybe listening to a little Katy Perry, and working off a server that's 1,000 miles away, sitting in a fabric. Well, it's a beautiful new world. A lot of stuff has changed. A lot of great stuff has happened. One thing's for sure, we're much more dependent on the internet and wide area networking than we were before. And our networks are getting a lot faster, but we're pumping a lot more data over those wires as well. And that bandwidth that we use, that bandwidth costs money, and the time that we spend waiting to transfer stuff, that hurts productivity. And I do know one thing, and I'm sure this is true of everybody here, nobody likes waiting. I sure as hell don't. So we've got this technology in Windows that we call BranchCache, and it's designed to help you turn this into this. Putting a cache of data, surprise, surprise, isn't that clever, in your branch office to try and reduce some of the use of that wide area network that you have and make things faster for the people in the office. And there's lots of opportunity to do this if you've got applications that you're running on Windows servers, like running on VMs, either in your own cloud or rented up in some public cloud. You can use BranchCache and you can make your stuff faster for free without writing any code. And then in this session, we're going to expose the peer distribution platform, which is an API set that we have that you can use to hook new apps that might use a public cloud service like Azure Storage. And then finally, if you've got a hybrid cloud setup where you have a couple of data centers, maybe one that you own and one that you don't, where you can't put your own hardware in, you can use BranchCache to speed up that data center to data center connectivity as well. And that's what we're going to talk about today. That's the opportunity that we're chasing. Okay, so there's 4 major sections to this talk. The first one's this. I'm going to cover this. We're going to tell you how you can get free cache. So this is how you can use BranchCache without writing any code, speed things up, and save a whole bunch of bandwidth and make things faster. Then I'm going to turn you over to Andrew here, and he's going to introduce the platform that we have in Windows. We haven't talked about this very much leading up to this point. He's going to bring you through the gory details of our API, tell you about all the funky stuff that you can do with it. Then it's going to come back to me, and I'm going to show you how you can use our platform to go and speed up communication with a cloud service like Azure Storage. And then we're going to finish, we're just going to touch on the opportunity to extend BranchCache and play in our system. So those are the 4 major areas that we're going to cover in our talk. Okay, we got 60 minutes. I'm going to jump right into it. I'd love to have time for questions at the end. So the first thing, free cache. How you can get sped up without writing any code at all. Okay, so BranchCache is a platform that we ship in Windows. We put it in Windows for the first time in Server 2008 R2 and Windows 7. What we do is we expose a set of APIs that can be used to hook protocols so that they can take advantage of a multi-machine cache in an office. And so what we did is we used our own platform to go and hook the implementations of HTTP and SMB in Windows, and any apps that use those protocols for communication between BranchCache-enabled clients and servers, those apps just get faster. They don't even need to be aware of what's going on underneath. And then we've got this little gray box there that's way over on the side, and that represents the fact that this platform is public, and you can use it to do a lot of other cool things, and that's what we'll get to later on in the talk. So we have a platform in Windows that we've used to hook protocols. Apps that use those protocols get the caching without requiring any changes. This is kind of what it looks like. So there's 2 different modes that you can set up this multi-machine cache in. This is the first one. It's what we call our hosted cache mode. It's one of the ways that you can use BranchCache. And in this mode, you set up a server in your office, and it's responsible for holding on to cache data and serving all of the clients. So this is kind of how it works. So say Bob comes in the morning at 7:45, fires up his Windows 8 laptop, and he wants to go view some images right on a BranchCache-enabled web server that's far away. He could be using any number of web apps. In this case, let's say he's using Internet Explorer. So he fires up his laptop, and he goes and he makes a request to that server that's very far away, and this request is marked as being BranchCache capable, or coming from a BranchCache capable client. So the server sees that and says, oh, this guy understands this whole caching system, and it sends back identifiers instead of data. So identifiers are a really small representation of the data that he wants to optimize. Okay, his computer, without him knowing, will take those identifiers, feed them into BranchCache, and he'll go and query this hosted cache server and see, is what I'm looking for already available locally? It's not, because he's early, the penalty for being the first in the morning. So the hosted cache server replies and says, I don't have what you're looking for. He goes back over the wide area network link and downloads what he's looking for. Now, once he's got it, he makes an offer to the hosted cache server and says, I've got something that you might want that other people are likely to be interested in. So he sends up those identifiers, and then the hosted cache connects back, downloads the stuff, and holds on to it so it can be made available to other people in the future. Okay, Alice comes in 15 minutes later, fires up her laptop, goes to view that same set of images, that same document on the remote server. She downloads those identifiers. She goes and queries the hosted cache server, pulls it locally. It's nice and fast, saves a trip over the WAN link. So that's our hosted cache mode. Server's responsible for holding on to the data for people in a branch. Okay, we've got another one, distributed cache mode. And this is a great way to set up BranchCache and get acceleration when you don't want to have a server in a branch office or when your customers don't want to have servers in their branch offices. And this is how this one works. So Bob comes in at 7:45, fires up that laptop, goes over the WAN link, goes and downloads identifiers instead of data. And now that he's got them, his machine goes and does a little multicast shout, tries to find another computer that's local, that's already got what he's looking for. So he's the first person, so he doesn't find anybody. He goes back over the WAN link, downloads the data, and holds on to it so it can be made available to other people in the future. Okay, 15 minutes later, Alice comes in, downloads those identifiers, does the shout, finds Bob's PC, pulls it from him, done. So hosted cache mode, server in the branch, distributed cache mode, infrastructureless, clients share between each other. Okay, so what are these identifiers that I'm talking about here? What are you doing with my data, Tyler? So what we do is we take your data and we cut it up into pieces, and those identifiers are derived from hashes that are calculated over the pieces of the content that you're trying to accelerate the download of. So we do this. We take your data, we run it through a fingerprinting function. This is like a mathematical transformation. And then what we do is we look for key points in that mathematical transformation that become the boundaries of your blocks. So those become the split points for your data. And then for each one of those blocks, we hash up all the data inside, and we compute a really small identifier that we can use to refer to that content when we're exercising this big BranchCache system. So this is actually a new improvement in Windows 8. What I'm showing you here, like I said, BranchCache was first introduced in Win 7 and R2. We had kind of big fixed-size pieces. Now we've got much more sophisticated variable-size pieces. You might have heard that we've got a rather ambitious project with a file server team where we're deduplicating data on disk. Well, both teams are using the same technology. We're borrowing what they're doing and actually reusing chunk and hash calculations that might have already been done. So you've got much smaller variable-sized pieces this time around that let you squeeze a lot more out of BranchCache. Anyways, identifiers are hashes computed over chunks of data. Okay, I want to talk about security. So BranchCache, you got this multi-machine cache of data. Is there opportunity for data to leak, right? Is this system really safe? And it is. First of all, BranchCache is capable of accelerating communication that happens over end-to-end encrypted links. So if you're using HTTPS, IPsec, TLS, anything like this, BranchCache can speed that communication up without having to deploy any boxes or certificates or any kind of intermediaries. We work in an end-to-end manner, which means whatever encryption you got between client and server, that's fine. It really doesn't matter. Okay, second thing here, we keep data encrypted on disk. So once we cache stuff, we keep it safe, so even if your computer wanders off, it's okay, nobody's going to be able to make sense of what's there. That's also a new improvement that we have in this release of Windows. Okay, and then the final thing here, and I'll explain this in the next slide, we're very careful not to give out access to data to people that are not authorized to see it. So even though we've got a cache of data in the branch office, we don't hand it out to just anybody. We've got a model to make sure that if you're getting stuff out of the cache, you're supposed to be able to see it. And this is how that works. Okay, so I'm going to take you through a BranchCache flow. I've got a client, and I've got a remote content server. And I'm going to try and download something, and I'm going to use BranchCache to do so. So I make a request. I'm going to go and download those hashes, those identifiers. And the server is going to authenticate and authorize me the way that it would if BranchCache weren't in the pictures. It's going to check me out. Now, only if I'm allowed to access the piece of data that I'm looking for is it going to give me back the identifiers. So I can't get the hashes unless the server wants me or would let me get the data. So it checks me out. It sends back the hashes to me. And now I've got them, and I actually use them, or I split them up, and I create two different identifiers for the content. So it's a little bit more complex than I suggested before. We've got a public piece for identifying content, and we've got a private piece for dealing with content. And what this lets us do is we can shout out that public piece, say, hey, I'm looking for this little particular piece of data, and we can find somebody else who's got it. And then when we find that person, that other client will encrypt the data using the private portion of the identifier. So I got to get both the public and private pieces from the content server. It won't give me that stuff if I don't have access to the data. And I need both of these in order to find and retrieve data from within the branch. So that's how it all comes together, and that's how we can guarantee that BranchCache doesn't hand out access to data to people that are not supposed to get it. So it's a very important principle of what we built. Okay, BranchCache is off by default. You've got to set this up. It's not a big deal. There are a few things that you have to do in order to get this working. First of all, it's off on clients, and you need to enable it on clients for them to start caching. You can run a single PowerShell commandlet to do this. You can choose the operational mode. Are you going to be our distributed cache, or are you going to work in hosted cache mode? So you can do that from the command line, or you can use group policy. Now, we've simplified this model also in this release such that BranchCache doesn't require any office-by-office configuration. So if you've got somebody that has a lot of branch offices or a lot of big offices, they can actually drive the BranchCache deployment with a single group policy object to make it work everywhere. The way this works, basically, is the group policy object will tell clients, go and use the distributed cache mode, be peer-to-peer, unless you automatically detect a hosted cache server in your location. So if you find one, use it. If you don't, go to our distributed cache mode. It's a much simpler model than we've had in the past. Okay, so that's how you configure your clients to use this thing. If you want to set up a hosted cache server in your branch, it's got to be a Windows server. You tell it to operate in hosted cache mode. It's one PowerShell commandlet that you run. And you can tell it, register your presence by registering a service connection point for automatic discovery. So you can tell it, make yourself available to clients, let them find you. And then we've got a new capability in this release, and that is you can deploy multiple hosted cache servers in a branch office if you want. So if you've got a really big location, you've got thousands of people, and those people are accessing stuff that's very far away, that's off in the cloud, you can have a couple of servers that are going to stack up in order to deal with the load on the cache that those clients are going to present. Okay, back in the headquarters, at the cloud, or the data center side, the BranchCache feature is not installed by default on servers, so you've got to install it. If you've got a web server, if you want to take advantage of our HTTP integration, you just install our component and you're done. We'll start handing out hashes to BranchCache-enabled clients. If you've got a file server, it's a few more buttons you can push, knobs you can turn. You can enable hashing on a share-by-share basis for the whole machine. There's just a little bit more options for you if you want. But that's it. That's what it takes to set this up. You've got to turn it on the clients. You can tell them, figure out your mode, automatically find a hosted cache server. You can set up multiple hosted cache servers if you want. That's what's involved in deploying this thing. Okay, now I want to take it for a spin. Right? That's some early details about this thing, and I got a little demo here to show it in operation. So Andrew's going to run this for me, and I'm going to talk you through it. What we've got here is we've actually got 4 virtual machines, but we're only going to show you 2 in the course of this demo. So what Andrew's doing right here is he's just fired up a Internet Explorer, and he's gone to go and view a website that's sitting on a web server that we have running on one of the virtual machines here. Andrew, did you start the network emulation software? No. Okay, so sorry, we had a little technical difficulty before we started. I'm going to show you the other machine here. This is our app server. You're going to have to log into that. What we're doing is we're running a little piece of network emulation software in here. It's called the Network Emulator for Windows Toolkit. You might have heard of this before. It ships in a couple of SDKs that we have. And what it does is it slows down connectivity to this machine, so it looks like other computers connecting to it are connecting over a WAN. So even though we've got other machines that are on the same vSwitch, connectivity or communication between them is going to be kind of slow. So we actually started off the demo here, and we went and we accessed a website right there, and it ended up loading up very quickly because, of course, we didn't have the emulation software running. But we're going to show you an experience that's kind of LAN-like. Okay, so client 1 comes in. He loads up this website. It typically takes a little longer, but we didn't have the emulation software running. So what we're going to do now is we're going to save a document. And you can see it's a little under 2 megs. It's about 1.7 megs. Saving this document takes a little bit of time. You've got to wait for it to come down, 78% or so. 90, and we're done. Okay. So you can tell that it takes a little bit of time. This is a kind of a typical branch experience without any acceleration. All right, let's flip over to the other client now. And we're going to go and view that website, and it loads up very quickly. And what's actually happening here is those images are coming from the BranchCache cache. Now I'm going to show you BranchCache really in action. Why don't you save that same document from the second client? It took us a long time before, bam, we finished immediately, and that's because that data, we're able to pull it from the other client or the hosted caches we have set up in this manner. So that's BranchCache actually kicking in and speeding things up. Now I want to show you one other little thing here. You want to save that white paper as well. So we've got 2 different documents that we're downloading from this server, and they're quite different, but they've got chunks in common. And this is some of the new work that we've done. So when we save that second file, we're able to find the pieces that were in common with the first document, pull them from the cache, and only get the new stuff from the remote server. So that's new work that we've done, and that's why the second document, even though it's the same size, comes down relatively quickly. So that's our branch cache caching in action. It's kind of slow for the first guy. He caches it. It's quick for the second person. And we didn't have to do anything to this website in order to get it fast like this. OK, so that's the first demo. I got another one little later on as well. You want to flip us back to, OK, here we go. All right, I'm going to turn you over to Andrew now. He's going to talk about our platform and the protocols, the API. Thanks, Andrew.
Hello, everyone. My name is Andrew Cunningham. I'm a software engineer on the BranchCache team. And I'm going to show you how you can use the peer distribution APIs in order to instrument your own protocols and your own applications. Now, I know that name peer distribution, it might seem a little bit strange. That's just the name we gave to the underlying API platform that you can call into in order to exercise BranchCache. Now, we originally shipped BranchCache in Windows 7 and Windows Server 2008 R2. So that means these APIs are already available for you to use. If you just go on MSDN, search for peer distribution, you'll find the detailed API specs for all the APIs that I'm about to describe to you today. So let me show you how this all fits together. BranchCache itself is not a platform that's generally aware of what protocols or what applications it's optimizing. BranchCache is meant to be very generic. It lets you optimize many different kinds of protocols, many different kinds of data. Now, we've gone and used this underlying platform, and we've hooked in our SMB and HTTP protocols so that they're seeing some of the optimizations you just saw in that demo. Now, as Tyler mentioned earlier, if you're built on top of the SMB or HTTP protocols, you don't need to do any work in terms of coding in order to get these optimizations. Now, if you're not built on top of these protocols, these peer distribution APIs, that's your interface into the BranchCache platform. That can let you instrument your own protocols, your own applications in order to get the same benefits. So let me give you a very high-level view of how the peer distribution APIs work. Here I have my content server, and I have a client who's going to go to try to retrieve some piece of data from the server. Now, when you're using these peer distribution APIs, you want to think about it in terms of 4 high-level steps. Your first step, you're going to generate the identifiers that allow clients to find content within the branch office. Now, this is a process that you'll see referred to as publication in the actual APIs. So what you're going to do, you're going to take your data that you're interested in optimizing, you're going to push it through our APIs, and we're going to take that data, chunk it into various different pieces, generate hashes against those chunks, and then store it in our cache for later use. Now, once you have that, you can retrieve those identifiers from BranchCache, send them across the wire, and get them to the client. That's step 2. Now, step 3, once you have those once you have those content identifiers, you can use those, search for data within the branch office, and pull data from BranchCache without, and if you were unable to find the content within the branch office, then you're going to have to go back to the content server, download the actual content, and then add that data to BranchCache. That will make it available for other peers. All right, so let me take a deeper dive into this, show you how we hooked the HTTP protocol in order to use these APIs. So what we're going to do, we're going to send a very normal HTTP request up to the content server in order to download some image. Now, the first thing that we needed to do was we needed to tag this request, let the server know that this client is BranchCache capable, he's interested in downloading these identifiers and trying to use them to download the content. So the way we did that with HTTP is we added this accept encoding header and defined a peer dist encoding that just indicates that the response is going to contain the content identifiers rather than the actual content. Now, on the content server, we have a data store that we refer to as the hash cache. What this contains is just the information on those chunk boundaries and the hashes that we've computed. We're going to store those for all the content that's been accessed on that server so that we're not having to recompute those hashes on every request. So when you're retrieving content out of the hash cache, you're going to retrieve it using the key that we just referred to as the content ID. That content ID is just a byte array. It can be in any format you want. In the case of HTTP, we're just going to use the URL as our lookup into that cache. That can just as easily be a file path or anything else that makes sense in the context of your protocol. Now, as for the APIs themselves, you're going to see a very similar pattern repeated in several of our APIs. You're going to open a data stream. read to or write from that data stream, much as if you were reading or writing from a file, and then you're going to close that handle in order to save resources. So in the case of retrieving content information, you just call peer-to-server open content information, pass in that content ID in order to look up into the cache. That opens up your data stream for you. And then you're going to call that retrieve content information API, keep calling that until you've retrieved the entire content information buffer, and then you can call close content information in order to clean up resources. Now, if you didn't have the content already published, this clicker is not going, there we go. All right, if you don't have the content already published, you're going to need to publish it into our hash cache before you're going to be able to retrieve those content identifiers. So here's the APIs that you use to do that. Again, it uses a very similar stream semantic. You're just going to call peer-to-server publish stream. That opens up the stream. Then you keep calling add to stream in order to write to that. Keep doing that until you've pushed all of the data into BranchCache. And then you just call complete stream. That lets us know that you've managed to successfully push the entire content into BranchCache. We can close that off, finish calculating our hashes and identifiers, and save that into the cache. Then you just call close stream handle. That will clean up all the resources associated with that. Now, once that's done, everything's stored in the hash cache, and you're able to call open content information on that, retrieve the content identifiers. So now the server, he's computed everything, he's retrieved it from the cache, he's ready to send that over to the client. So we have our HTTP response here. We've just indicated that the content encoding on this response is peer-dist in order to say that these are the content identifiers rather than the actual original content. So within the branch office, every single client in that branch office has its own data cache. That data cache is going to contain not only the actual content that we have cached, we're also going to save the information stored in these content information structures so that we can look it up later and use that to search for content within the branch. So the first step that the client is going to do after he's received this HTTP response, he's going to take that content information, call peer-dist client open content. That opens up all the data streams associated with this particular download. He's going to call add content information and keep pushing that content information structure into BranchCache, call complete content information once he's done. Now, once you've done this, BranchCache has all the information it needs in order to search for that content within the branch itself. So the next step that you need to do is call one of these read APIs in order to pull information out of the cache. Now, I just want to point out that when you're calling these read APIs, you don't need to worry about whether you're in distributed caching mode or in hosted caching mode. That's all abstracted out for you. When you call one of these read APIs, we're going to look at our own configuration, and we're going to decide whether we need to try pulling that information out of another peer in the branch office or from a hosted cache server. Now, we have two separate APIs to allow you to read. The first one is peer-dist client stream read. Again, that's much just like reading from a file handle, and you can just read the entire content sequentially from there. If you just want to pull specific chunks of data out of the cache, you can pass us a byte offset and a length for the content range that you're interested in retrieving, and we'll go and pull just that specific information out of the cache for you. Now, if you're able to find everything within the branch office, at that point you're done. You can just call peer-dist client close content. That releases all the client resources associated with the operation. Now, if some of the data was missing from the branch office, you're going to have to go into the content server and retrieve that information from the cache. Or sorry, retrieve that information in order to add it to the cache. So here we're going to make another HTTP request. We see in this case, we've excluded that peer-dist encoding from the accept encoding header. That tells the server that the client isn't interested in retrieving that content information. He's going to go and pull the actual content and send that in a normal HTTP response down to the branch. So the client's going to take that content, and you can just use the same content handle that you got when you called peer-dist client open content. Use that just to push all the data into the branch office. Then you can call peer-dist client close content, and at that point you're done. The content is available for the next peer to download it. So just to recap, you just have four main steps when you're calling these peer-dist APIs. At first you have to publish, generate those content identifiers, then retrieve those content identifiers from the cache, send them across the wire to the client. Then you call add content information and read in order to try to retrieve that content within the branch office. And finally, if you had missing data in the branch office, you can just add that data into the cache, and it's available for other peers.
OK, thanks, Ben. So that's what's going on in Windows, right? If you're going to use our HTTP integration, that's actually what we're doing under the covers. Just a little illustration of how if you want to go hook something of your own, you've got your own protocol that you're tunneling in HTTP. Hell, if you want to go use this to hook FTP, that's a model that you can use to figure out how you're going to work. Okay, so this is something that I'm really excited about, and this is something that we haven't talked about very much. But you can use BranchCache when you're communicating with a public cloud storage service. And that might be one that doesn't natively support BranchCache. It's not going to do any work for you. It's not going to generate those hashes and send them back. But that doesn't mean that you can't use our technology to accelerate those downloads. And now you might think about moving to something like Windows Azure Storage or Amazon or something like that. Where you can get storage for cheap, and you can distribute it well, and you're going to push that stuff up in the cloud. But of course, then you're going to be moving those blocks between you and God knows where. It might be really far away. So BranchCache can be a good solution that can really let you take advantage of that cheap storage without having to pay the hit of the latency and the bandwidth of downloading stuff time and time again. So this is kind of how it works, right? You can generate hashes on the client. It doesn't have to be. You don't have to generate those hashes on the server. So this is kind of how the model works. Let me show you with a little animation. Okay, so let's say we've got an admin, and he's going to upload something to Windows Azure Storage so that other people can download it. And what he's going to do is he's going to take his file. I can't stray too far from the machine. He's going to take his data, and he's going to run it through the peer distribution API. So he's going to generate hashes for his stuff. And what this is going to end up doing is he's going to be left with his data, and he's going to be left with his identifiers in two separate blobs, two separate files. Let me just upload both of these things. So we're going to upload the data, and we're going to upload the identifiers. And these two things will exist as separate blobs up in the storage service. Okay. Second guy shows up, and he wants to go and download that data, and he wants to use BranchCache. So what his client is going to do is it's going to explicitly download the hash blob. And then it's going to take the hashes that are in that blob, feed them through our APIs, and that's going to trigger the search. And if BranchCache works, if somebody else there in the office has already downloaded this particular blob, the BranchCache APIs will feed that data back. Okay, now if he fails, if he happens to be the first person in this location looking for this one specific blob, no problem. He can go back over to the server that's remote, and he can download the data. And so we're sort of following the process that Andrew just described here. Once he's got that data, he can feed it into the BranchCache APIs, and we'll hold on to it, so whoever else comes along and wants to download that same blob, they can do it as well. And so the gist of this is you do the hash generation on the client, and you upload both pieces. And this means on the server side over there where the cloud is, that can be anything. Any place that you can hold blobs of data, you can play with BranchCache with. Okay, so I want to take this for a spin. This is the next thing. This is the second demo that I have here. This is an app that we wrote a couple of weeks ago, and it's kind of a simple mock-up of what might be a really serious cloud piece of software. What we've got here, forget about the regulatory things that might stop for this from actually happening, but we've got a medical X-ray image viewer. So imagine you've got your X-rays that are getting stored up in the cloud, and this means you can hop from office to office to office, and your doctors are going to be able to pull that stuff down. You probably know X-rays are typically pretty big, right? If you've got a good doctor and he's going to look at some kind of high resolution, he's probably going to be dealing with big images. So that's a lot of bandwidth that we're going to spend, and even more time that you'd spend waiting in a doctor's office. Okay, and then there's another scenario. Imagine that you've got two people in the one doctor's office. You've got somebody who's going to take the X-ray and somebody who's going to check it out. Well, it kind of sucks if both of those people have to transfer back and forth to the cloud in order to get things working. So we can speed that up too. Okay, so let's start off with this. Andrew, you want to take this for a spin? Why don't you download one of these images? So it's kind of a funky-looking app. You can see down in the corner there, we're spitting out a little log information to show you what's going on. So it's kind of hard to see if you're a distance away. We just downloaded an X-ray of, let's say, my chest. That's my name up on the top of this app there. And I don't know, I think that looks good. I feel pretty good. We weren't able to pull from BranchCache. The search was unsuccessful, so we ended up going back to the cloud and downloading the image. Now what this app does is it takes that X-ray, and now that we're done, it's going to feed it into the BranchCache API so that it's nice and fast for the next person to come around and download. And we're not going to spend any bandwidth doing so. You want to pull down another image? See what else we've got here. Okay. So we've got a weight, right? The X-rays are big. These X-rays are really only about what are they, 1.7 megs, something like that. But you still got to wait for them. We've got pretty good connectivity here. I don't know what body part that is. I guess we're fine. All right, you want to pop over to the second machine now. And we're going to use the same app. We're communicating with real Azure storage here. It's up in the cloud. Let's load that up, Andrew. Okay, so bam, you can kind of see in the log down there, down in that text down on the left-hand side, that we're searching with BranchCache. The search is successful. You might have noticed the image loaded up super fast. We pulled it from the cache. Okay, you want to load up that second one as well? Boom, we're done. So that's BranchCache accelerating the blobs using the process that I just described. There's no code running on the server. We're hashing stuff up on the client, uploading both pieces. Okay, so now let's come up with a new scenario that I want to test out. And this is a neat property of doing BranchCache in this way. When you upload stuff to the cloud, you can also stick it in your own cache right away. So you can hold on to it so that BranchCache can be used immediately. So I'm going to upload stuff, and I'm going to hold on to that data, and that means other people are able to get it from me. So what this lets you do is it lets you use the cloud as a control plane and BranchCache as the data plane. So let's say we had something like this that was doing document management. I was uploading documents. Well, I can create a new document, stick it in the cloud with the hashes, stick it in my BranchCache cache, and then tell you, hey, why don't you go edit it? And you're going to be able to pull it from me immediately. So even though we're using the cloud very far away, it gives us kind of a LAN-like experience because all of the data transfers are happening locally. All right, so let's imagine this scenario. I pop into the doctor's office and my stomach is killing me. It hurts so badly that they're going to x-ray me and a doctor's going to check me out on the spot. So I'm going to have two different people that are running this particular piece of software. So somebody's going to scan me and they're going to upload an image. So serious x-ray.jpg. Okay, so we upload that and we're going to stick it in the BranchCache cache at the very same time. Okay, so I got my x-ray. I roll into the doctor's office. He's right down the hall. They're going to fire up the same app and they're going to download from the download from the cloud. You want to switch over to the other client, or are you on the? Okay. So Andrew's my doctor. He's going to check me out. You want to load it up, and bam, that happens immediately. So they find out why my stomach is buzzing without me having to wait for the network. Right, so it's a good scenario, LAN-like experience. Somebody uploads, goes in the cache right away. All the communication and coordination is happening with Azure Storage, but the transfers are happening locally, so it's fast and we save bandwidth. So it's a model for using BranchCache with the cloud. Okay, that's it. That's our demo. We can play around with this. A little bit later, we've got a few more features of this thing, but that's what I wanted to show you. Okay, so this is the sort of last little bit here, and it looks like we're going to have a good chunk of time for questions, which is a great thing. There are some opportunities to play ball with BranchCache if you want. So the very first and most obvious thing, and we've had some great partnerships where some people have made some really good products that do this, that hosted cache workload. If you have a piece of hardware that you're selling into people's branch offices, it's a great thing if that can support the hosted cache workload. Our hosted cache mode ends up working a little bit better than distributed cache mode for a pretty obvious reason, and that is in our peer-to-peer model, you can download something onto your laptop, and you can hold on to it there, and then you can close your laptop and walk out the door. And if you do that, the stuff that you have cached is gone. Right? Until you come back, of course. But it means that the distributed cache mode just doesn't get you quite the same level of savings that hosted cache mode does. And there's a little extra monitoring and control, and it's just a little bit better if you have a server that's running in the branch for it to operate as a hosted cache. The other thing is that hosted cache workload, it's not computationally expensive and can very often run alongside other things that you might have running on a server in an office location. So it's a real nice little add-on to something else that's already happening in the branch. So if you have a device, you have something like that people are deploying in offices, it's a great thing if that thing can run the hosted cache workload alongside those other things that it's doing. Okay, this is the sort of a big complicated picture. This is a little breakdown of all of the things that are happening in the BranchCache system and all of the different points where things hook into BranchCache. Okay, so the first thing, you can see that we've got these little abbreviations, and those are the names of the protocols. So if you want to go check this out, if you want to read bits and bytes, you can do that. You can find out what we're putting on the wire in every case in Windows 7, and also the innovations that we've introduced this release in Windows 8. Okay, so the very first thing, we've hooked HTTP and SMB, and the way that we've hooked those protocols is documented. So if you want to go and look at that and find out all of the headers, believe it or not, there's a little bit more to the HTTP integration that Andrew told you. I'm sure that won't surprise you, but it's not that complicated. And then all of the stuff that we've got for SMB 2.1 and 2.2 is documented as well, so that's up there. Now the other thing, these protocols that we use, that multicast shout that we do, that's a shout that's based on a protocol called WS Discovery. It's a little UDP multicast. You send out a single packet and say, I'm looking for a device, or in our case, a block of content with this numerical identifier. So we have a very specific way that we're using that WS Discovery protocol, and that's out there if you want to go and look at the details of that. Now the hosted cache, there's actually two protocols that come in or kick in when you're using the hosted cache. The first one is we've got this offer protocol. So the hosted cache is the only element in the BranchCache system that ever gets offered data. Everybody else only pulls on demand. So this is also another interesting property to tell you about BranchCache. If you download something and you hold on to it, you don't push that to anybody else. You only ever cache what you have downloaded. It's another kind of important part of our security model. But you only ever cache what you've downloaded. The hosted cache is an exception. We have this one protocol where we say, hey, I got blocks matching these identifiers. Do you want them? That's up there if you want to take a look at the details of that. And then we have our download protocol, and this is the thing that we actually use to suck blocks from one machine down to the other. And it's based on HTTP. Just connect one machine to the other, request a certain number of blocks, download them, add them to the cache, or feed them upwards to another application. The one thing that's not mentioned on here is we have a data structure, the one that Andrew spent a bunch of time talking about. It's called content information, and it's the big list of hashes that describe a chunk of data. That's up there. If you want to go and look at that structure and see the bits and bytes of how that works, we have that available as well. So it's these set of protocols, and these are the points at which you can interoperate with BranchCache. It's all of the places in which the BranchCache system comes together. Okay, so that's what we got for you right now. The little summary of this, again, that Windows running a hosted cache on an appliance that you ship into a branch office, that's a great thing to do. It's built into Windows, and it can run alongside other things, and we'd love to see people do that. Okay, a little summary of the talk that we gave you here. So the very first thing, right, BranchCache, it's simple, it's secure, and it's built into Windows, and you can use it for free. If you've got apps that are running on Windows that are using the protocols that we've hooked, they'll get faster, and you don't need to worry about it. So virtual machines running in your own cloud, in a public cloud, running on Windows, flip BranchCache on, flip it on your clients, just watch the multi-machine caching happen. Okay, the second thing, we do have this platform and this framework, and you can use this to do a lot of funky stuff. If you have other protocols, you can go and hook them to take advantage of the multi-machine cache in the same way. One thing that's important to mention, you may have protocols that are tunneled in HTTP. They can't really benefit the same way that something like straight HTTP GETs can, because you've got a lot of variance, right, in each HTTP send request response. Well, that's a great place to use the BranchCache platform to speed up your stuff. We've got a bunch of people that are doing this already. But we have this platform that you can use to hook new protocols, do other cool things. Okay, the third thing here, we showed you this. You can use this BranchCache thing to speed up communication with the cloud. So it doesn't have to be Azure Storage. I recommend Azure Storage because I could write that app in a lazy Sunday afternoon. But there are other places also where you might be dropping off blocks of content, and no problem. BranchCache can kick in. You just need to be running from a Windows client. Okay, and the last thing there, we'd ask you guys, consider using BranchCache on things that are going to ship out into branch offices. There are many points at which you can play with BranchCache, and you're welcome to do so. We'd love to talk to you about that. Okay, contact information. We're going to be hanging out up here for a little bit. In fact, I'm going to take a bunch of questions now. Following this, we're going to be at Ask the Expert. Following this, we're going to be at the Expo Hall, so we'll be hanging out there. And if you want to come and get your hands dirty with these demos, they do a lot more than we showed you than just what's on stage here. We can even show you the code if you want to get into it. We're going to do that. We're going to be at Ask the Experts tonight, getting a free dinner. And we're going to be at the Expo Hall again tomorrow if you want to drop by and see us. So please, come and see us while we're here. Aside from that, real easy way to get in contact with us is branch@microsoft.com. If you want to do any of this stuff, if you're going to extend our system, I'd sure love to hear about it. I mean, despite what my ex-girlfriend says, I do listen, and I'd love to hear what you have to say about working with our platform. Okay, final thing. I've only got one documentation and an article link because I don't want any confusion. Go to branchcache.com. Everything that you really need is there. There are links. You'll find our MSDN documentation. Again, if you really have a hard time finding something, I'm friendlier than most search engines, so just send us an email, and I'd love to hook you up and talk. Okay, we've got the mic here. People have questions about BranchCache. I'd love to take them now, and again, I'm going to be hanging out for a little while later. Yes, sir. What would you find? Oh, thank you. Thank you. Appreciate it.
Great stuff. Sorry if I missed this, but did you speak at all to cache management? I'm thinking topics like controlling expiry time or constraining the size of the cache.
Yeah, great questions. Okay, so this BranchCache thing, many times I've done this same talk just how to use BranchCache, not how to develop with it, and we go 75, 80 minutes. We go a lot longer than this. So let's talk about this. Let's talk about management of cache data. Okay, so by default, we reserve a chunk of your hard disk for storing blocks and for doing all of our caching operations. And what we do is we kick things out of that chunk of storage on a least recently used basis. So if you've got a block that nobody wants, that nobody cares about, it'll eventually stale out, and we'll replace it with something else that's more meaningful later on. Now, we have a maximum time limit of 28 days. So if you've got something that's been in that cache for longer than 28 days, we'll prune it. So this means that eventually any data that was cached with BranchCache is going to disappear. We're going to kill it all off. Now, that's a number that we're thinking about making configurable. There are a few people that want to turn that up and down for one reason or another, but we've got a mechanism for automatically pruning what goes into the cache there. Now, we built some new capabilities also into Windows 8 for managing the data that you have in your cache. It's been totally opaque until now, but we've got some tools that you can use to hash up stuff in advance and preload the cache if you want. So if you got hot content, like I had somebody a little while ago, they had this scenario where they had literally terabytes of educational materials, and then they had all these schools in Australia that were connecting over the kind of stuff that I had in the 90s. And so what they wanted to do was ship all this stuff out by SneakerNet and import it, and that kind of a scenario is now possible. So you can hash stuff up in advance, ship it out, and import it into your caches and make it available. And let's use BranchCache for something like a large media library. Did I cover all of your stuff there, all the things that you wanted to know? Sorry, you can shout it out and I'll repeat it. I didn't mean to make you come back. There's a few things about cache management you wanted to know. Sorry about that.
No, that was great, but you made me think of another question. I'm a Windows Azure MVP, so I care a lot about the cloud. I thought your cloud
All
example
right,
was great.
good stuff.
Would the demo you showed, would that work if I turned on the Windows Azure Storage CDN, the Content Delivery Network? So I'm using these edge cache servers.
Man, great question. Okay.
Would you have to do anything different there?
No, nothing's got to change. And the reason for this is, okay, if you're using the peer distribution encoding, the content distribution network that you have, it's got to be cool with that encoding. If it only likes gzip and identity and stuff, that might be a problem. In this case, we're dealing with the hashes. It's just a separate URL, a separate file containing all of the hashes. So if you've got the automatic content distribution network support like we've got with Azure, the hash file is just going to get spread out through the content distribution network the same way the data file would. So it actually works really nicely. You can end up retrieving a hash file from something that might actually be really nearby, and then it's super fast. So no, that mechanism works out, no problem.
Awesome, thanks again. Is there a sample available that shows this off? Piece of code.
We're working on that. Come and see us, and we'll show you some stuff. Yes. If you go searching right now, right? If you're going to write this app in the next hour, you're going to have to do a little bit more from scratch than you might in a little while. So we're working on that one.
Thanks.
Great questions. Thank you. Okay. Yes, sir. What can we do for you?
Are the latencies slow enough that you can deal with like smooth stream video and stuff like that?
I'm sorry. I didn't hear.
Are the latencies small enough that you can deal with smooth stream video?
Yeah.
So small HTTP packets like.
Okay, smooth streaming is an interesting topic because we have a few different, like you end up with multiple data streams that are actually separate chunks of data. We do work well for video, right? I mean, especially if you have any amount of buffering. Here's how the latencies look in the BranchCache system. So when you go and shout and you search for a piece of data, we will wait a very maximum of 300 milliseconds before we decide we don't have what you want and we're going back over to the server. In the hosted cache mode, it's much more interactive because we've got a unicast query of the hosted cache, which will tell you the data's not there much faster. So anyways, the place where you've got to worry about latency, of course, is the negative case where we don't have the data in the branch and we're introducing a little bump because you've got to go back to the server to get what you want. And it's 300 milliseconds is the maximum delay that we'll introduce there. Right, so that's how the latency works. Right? And us otherwise as BranchCache, we're kind of unaware of the app above us. It's just we'll wait in a certain amount of time before saying we don't have what you're looking for. I can tell you that we have had many people that have used this for video to quite some success. I hope that helps. Other questions about BranchCache, other things? Happy to answer the cache management one. That's a good one that I left out. A few things. We've got a lot more tools in this release. You want to go play with PowerShell, that's there. The API surface that we have works on Windows 7. So if you wanted to build an app like this Azure Storage app, you can actually do that using stuff that we already shipped. Now, we have a lot of advancements in this release that make BranchCache a much better platform for working with the cloud. For one thing, we've changed the way that we cut up content. I talked about this. So we are a lot more effective at saving bandwidth because we're way more likely to find duplicated blocks in different files or different flows of content. And we can tolerate small changes in large files really well because we've got this sophisticated mechanism for breaking up data that we borrowed from the file server team. And then the other thing is, BranchCache in our previous release, we were really thinking about branch offices. We were thinking about locations of about 100 people. And that's not true so much anymore, right? You can use BranchCache in a way wider variety of locations now. And one of the reasons for that is we've done a bunch of work to make our stuff more performant. We're going through a very elaborate high-scale testing to kind of figure out where our ceilings are. And the last thing is we support multiple hosted cache servers, so you can deploy multiple servers to scale up that hosted cache load so that it can serve really big offices now. So this means like we're a much better platform for the cloud because before we were a good platform for the cloud for sort of small offices, and now we're good to go. You can have really large locations where you're moving all your stuff out. At BranchCache is appropriate, so it's bigger than the branch office this time around. Okay, sorry, I might have worked that into my talk. Other questions, other things that we can tell you about BranchCache? Okay, well, if the amnesia or it wears off, you have a cup of coffee and you remember what you might want to ask, we're going to be kicking around, and I'd love to talk to you guys, so please come and see us. Okay, thanks for your time. I appreciate it. It's great to be here. We'll be at the booth, and I hope to see some of you later. So enjoy the conference.